So today I'm gonna talk about Siemens S7 1200 family PLC ET200 SP modules, and I will talk about analog input signal. So here is wired analog input signal from 0 to 10 volts, and on this card it's wired 4 to 20 milliamperes to wire transducer sensor. Yes. So imagine situation as follows. Operator comes to HMI and see that there is pressure, let's say 5 bars. It could be anything. It could be temperature, it could be distance to some object. It depends on you, what kind of transducer do you have, sensor do you have, and application. But let's talk about the bars. He goes to the maintenance and says to electrician, okay, valve physically is closed, pipe is disconnected, pump is let's say turned off, and I see on the physical manometer it shows 0 pressure, but on HMI I see 5 bars. So something is not okay. And then what to do for electrician? How to solve this issue? Because it can be issue on program itself. It could be an issue with analog input. It could be wiring issue, or it could be sensor issue. So where to start and how to solve it? First thing that I would suggest to do, right now we are only talking about this reading. This reading is from 0 to 10 volts. Yes, so let's focus on this one. First thing to do, I think the best way is to just disconnect completely the power to analog input. So right now wires are disconnected completely. Obviously device should be stopped, maybe in emergency mode, so process should not run. So what he should see, 0 bars. 0 bars. If he sees anything else, then it means the problem is in PLC side or in analog input side. Maybe it's damaged somehow internally, something going on. Cables removed, it should show 0 bars. If it doesn't show, you need to ask your PLC programmer for help and figure out what's going on. But most likely the problem will not be in the program or in the analog input side, because it's very rare. Second case, let's say wires are connected. Okay, there is no pressure, but it still shows a little pressure. Okay, it shows 1 bar. There is no pressure, it should show 0. Sensor is connected right now. So it could be an issue with wiring. Right now we have this 1 bar, but actually negative contact is disconnected from PLC. So when I connect negative contact here, we have 5 bars. Okay, because right now I hooked up my bench power supply here. I don't have actual sensor. So from my power supply I send 5 volts and this shows 5 bars. Now it's good idea to have some sort of diagnostic inside the HMI panel. So, but some of these diagnostic settings should be only for electricians, for maintenance. need to be, this information is not useful for operator. So as you can see, our scale, our sensor is from 0 to 10 bars. And our analog input also from 0 to 10 volts. So right now I'm putting PLC sees 5 volts, and after scaling we have 5 bars. So this is okay, this is working fine. This is raw value just from the sensor itself. It's not scaled, it's just raw value. So in HMI I made acquisition time to refresh this value every 100 milliseconds, so it's, you know, refreshing quite fast. So if you have this screen, if you don't have it, you should ask to make one, yes, but if you have something like that, and if you see, right now I'm looking only to the raw value of the sensor. So 0 to 10 volts transducers and the line, they are susceptible to interference. And as you can see, the signal, raw signal is jumping. But this is actually, well, it's kind of normal. But if it's jumping in thousands, okay, I will, with my bench power supply, try to simulate that. Okay, it's jumping a lot. You know, it's jumping in thousands. That could definitely indicate the problem is with transducer itself. You need to change sensor. And if your sensor, let's say you don't have at this moment sensor from 0 to 10 bars, but you have sensor from 0 to 20 bars. So this is why it's a very good idea to have these scales. So here you can just go and change high limit scale. And right now we put, let's say, again 5 volts, and we see around 10 bars of value. Yes. What needs to be remembered, if there is missing negative contact, right now I disconnected negative contact, only positive contact is connected to analog input, we still have this ghost voltage, and well, if electrician sees that, he needs to check wiring. Maybe put a better wire with some shielding and shield only one side of that wire to electrical cabinet or something like that, or remove wire from frequency drives, and if possible make this wire from 0 to 10 volts as short as possible, because longer wire will get more interference. One more thing I would suggest to do, let's say you disconnect completely your sensor. So sensor disconnected, it shows raw value as 0, yes. And you connect your bench power supply to this analog input, and you sweep the range. Okay, so from my bench power supply right now I'm outputting to input card 1 volt, it shows 1 volt here, and we have 2 bars. If I output 2 volts, I have 4 bars. So I will sweep the range. Okay, 4, 5, 6, 8, 9, 10. So if I sweep the range and these values are correspond to what it should show, that means that PLC program an analog input module is healthy. It definitely means that if you have some sort of a problem, the problem is either in wires or in sensor itself. So at least you know where to look. Change wires. If that doesn't help, change sensor. Well, the best way, obviously, would be to have some sort of process calibrator, because you know bench power supply is it kind of needs some power source, and it's not that convenient. If you have some process calibrator, let's say LB02, Nercy has a cool one, Mr. Signal has awesome one, but they are a little bit expensive. Fluke process calibrators, it's very expensive, but they are very good. So, but you know, electrician on the floor most likely will not have these devices. But what he will have, definitely, he will have multimeter. Okay, so if we put our multimeter in diode mode, so right now we kind of have a source of voltage. Mine, this Fluke multimeter provides around 2.3 volts DC. So if I connect negative probe to negative analog input contact and positive probe to analog input channel 0, I see on my HMI that I am providing 2.3 volts, and it shows reading. So this reading is correct. So this is just for a sanity check, okay? This is working or it's completely dead. So you could use diode testing mode to check analog input 0 to 10 volts or I don't know, 0 to 5 volts. So yeah, you could use that. Best way, obviously, process calibrator, but this video about we don't have it. So now let's talk about 4 to 20 milliamperes analog input. So here, and yeah, we will focus on this side of the screen. Yes, so right now we have some value, and again raw value is very stable. If this raw value is going up and down like crazy, probably you have a problem either analog input card or transducer. So in that case we open the loop. Loop is open. So transducer is disconnected right now, and we have raw value minus 32,768. So remember that if you have open loop, okay, so then you have this negative value. If you have shorted loop, let's say your transducer is I don't know, have liquid damage or something, you should have plus 32,767. So it goes above maximum value. This means you have shorted transducer, wires, something with wires or something with transducer. Change wires, because wires usually are cheaper, yes, and you need to change wires because if wires are shorted and you lazy to change wires and you put new sensor, you can burn brand new sensor. So wires always cheaper. Change wires, then change transducer. As I said, this video about we don't have process calibrator. So how do we test this analog card is working or not working? What this analog input card, two wire analog input card, how it works? You basically have two wires. One wire provides voltage to your sensor, to your transducer. And this value comes back to your analog input card. So here we have 23.5 volts. It's not gonna be 24 volts, it's gonna be something less. So what you can do, you can apply Ohm's law, and you can actually put, let's say, 2 kilo ohm resistor. Well, this is not precise resistor, so don't expect it to be very exact, but yeah, we have 23.5, we apply resistance of around 2 kilo ohms, so we should get around current around 11 milliamperes. So I do that, and we can scroll to our HMI. As you can see, we have 11.5 milliamperes, and this is our bar reading, because this pressure sensor, it's from 0 to 10 bar scale. So that is correct. So this could give us good indication that the program working fine, analog input card working fine. Put resistor and you can check it like that. Now another thing could be that sometimes if your environment is very vibrate, something presses hitting or something, it's very unlikely, but you could have bad contact of this analog input card. So I will remove it completely. What you should expect to have, raw value should be 0. And obviously in this case red LED will flash on ET200, red LED will flash to the assigned PLC, and also very good tool to have in your HMI project. If you don't have that, probably you should ask to implement that. This is not alarms, but this is a kind of diagnostic buffer from PLC. So diagnostic view, not alarm view, but diagnostic view. And right now we will go to this diagnostic view, and what I see, we have text hardware component removed or missing, and here is the arrow, this indication arrow goes to the left side. Okay, arrow goes like that, so meaning this is incoming event. And if we press to select this event, what's going on, and press this arrow to check it out. So what we have here, we have information. 01X input output device, analog input for channel card is missing. And in fact, yes, it is missing. I just removed it. So it gives us a very good indication on what is actually happens, and where to go and how to fix. If you have firmware version 1.1, you cannot remove modules while this is working. But if you upgrade firmware, it's hot swappable, so it's not an issue. Yes? So electrician goes to 0.1 electrical cabinet. He knows that it's something going on with analog input card. He press it back and that's it. Our process is working. So you can obviously use your multimeter in milliamperes. So as you can see, so yeah, it's not good. I'm shorting this analog module, but you can imagine you have a transducer, you can check. So okay, this input should be between 4 to 20 milliamperes and it's giving me 40 milliamperes. So it definitely is a issue with transducer. Now another thing very useful to have these milliampere clamps, but they are also very expensive. So if you have one, you just put clamp, you don't have to break the loop, and you can measure what kind of current you having. But what I found, only 3 companies produce them: Fluke, Hioki, Milwaukee, and yeah, they are quite expensive. Now regarding communication error, so sometimes electricians sees these hashtags, yes, and he says, oh, okay, well, this is communication error. Well, it could be, but it also could be that programmer put this field. If we go back to our settings in our diagnostic field, it could be also be that programmer put like 4 digits inside this field. Only 4 digits can be displayed. Only 4 digits can be displayed, and if PLC analog input shows, well, after scaling, PLC sees more than 5 digits, this data sent to HMI, and you have these hashtags. It doesn't fit the field. It should be addressed. It should be fixed by modifying HMI project, but it's not a communication error. And communication error, okay, I will remove communication cable in HMI, and it takes quite some time to actually show it. So yeah, right now on all screens you have these hashtags, okay? So this is communication error. And usually what I do, from PLC I just use clock 500 milliseconds, and it just triggers a boolean, a bit. And this bit is shown here, PLC HMI communication. If this blinks, then it means communication is okay. If this doesn't blink, well, we have issues with communication. And when we restore, let's say, communication, and let's go back to our diagnostic view, we can see these messages: error on partner, no neighbor could be detected. 0.1 X input output device, port 1. So it could be an issue with this connection between ET200 and HMI. But it could also mean many things. Let's say ET200 lost power. okay, so or damage or something, and it's lost connection. Maybe the cable itself is fine, it works okay, but there is no power, so we have this. Also need to check time from time these contacts, because they are made from copper and they can rust, especially if you have a humid environment. So you just need to clean them, and you can try that. So yeah, if you like this video, like. If you don't like it, dislike, and I see you on the next one.